if you want. All right, so examples. I have a lot of examples I want to get through today. So let's start with this one. Okay, so solve x cubed plus 8x squared plus 16x greater than 0. Okay, so notice, first of all, this is a nonlinear inequality. What gives it away?
X cubed.
Yeah, we have a power greater than 1. Okay, so this is a third degree polynomial. Okay, so it's definitely not linear. And I also want to highlight, so since it's already, like all the terms are already on one side. Remember yesterday I said make sure all your terms are on one side? We already have that here. So it's a little bit of a gift. I don't have to worry about that. So let's jump into what this question is really asking us. It's asking for which intervals of inputs or x values will the outputs be greater than 0, which is a fancy way of saying positive. Okay, so this is what I'm going to be looking for. That's the question I want to answer. And it's already in the form that we need it, so we don't have to do any work at the beginning. Okay, so I'm going to write this as a function because, let me I talked about it a little bit yesterday, but here's a question. Why can't we multiply or divide by a variable across the inequality?
Because the variable can be either positive or negative.
Yes, very good. So if I have like x plus 3 over x is less than or equal to 0, okay? The question is, why is this illegal? There's another way of saying this. Why is this illegal? And Micah just said it. But you might be tempted to just clear that fraction, okay? Because that would just make it easy, wouldn't it? That's easy to solve, okay? But we don't know variables. Variables mean any number. So we don't know if it's a negative number. Okay, so that's why you cannot do this. I'm going to put a big circle around this. You cannot just multiply by a variable. If you do this, you automatically get 0 points on a test, on a final, because it is like, it's just such a big conceptual error. It shows me that you don't understand why we're doing the sign chart. We have to do the sign chart because you cannot do this. Okay. All right. So back to our sign chart. So step 1, let's find our zeros and our undefines, or our bad numbers. All right, so for zeros, I'm going to set my function x cubed plus 8x squared plus 16x equal to 0. Not greater than, equal. That's how you find the zeros. And then it's just like what we've been doing. We're just going to solve this like we already know how. Factor out the x. And then I have x squared plus 8x squared plus 16 is equal to 0. And that's x times what? How do we factor this?
X plus 4.
Yeah, very good. So x is equal to 0, or x plus 4 is equal to 0. We don't need to write it twice. There's my zeros. Okay. Now what about bad numbers or undefines for this function?
There aren't any?
Yeah, correct. Good, D'Angelo. So there are none because there's no denominator and there's no, oh, so just remember that polynomials, their domains are all reals. So there's no restrictions. And that's what this is. This is just a polynomial. All right, well, that's good. So now let's do our sign chart. And what I want you guys to do is as you go through these, try to follow the same pattern every time, okay? There's a lot of steps to this. When you skip steps or you try to do things quickly, you're gonna make mistakes. So part of like establishing this is getting a routine. So my routine first was make sure it's on one side. I wrote this as a function. Where is that? I thought I wrote it. Oh, I did not write it as a function. F of x equals x cubed plus 8x squared plus 16x. Okay, zeros, undefines, then we do sign chart. So on my sign chart goes -4 and 0, and these are zeros. And what I want to do is just do a little check right now to see if we include these. So let's go back and look at our original problem. Are zeros included?
No.
No, because there's no equals in there. Okay, so I'm going to put open circles here. Do you guys understand that the zeros mean if I plug -4 and 0 into that function, I'm going to get 0. And 0 cannot be greater than 0. That's not true. Okay, so 0 is not included. Maybe I should put that down there, but okay. So, all right. Now we have 3 regions to check. And I'm going to put, now what I would suggest doing is let's use the factored form of your function. See how I factored out x and then x plus 4 and x plus 4? Let's use f of x equal to x times x plus 4 squared. And in region 1, I have region 1, region 2, and then region 3. Now, what do we want to pick? What's a number we can pick in region 1 to check?
-5.
Yeah. And in region 2, how about -1? In region 3, 1. Okay. So so f of -5 is going to be -5 times -5 plus 4 squared. You guys get that this is the same function as above, right? It's the same as x cubed plus 16x squared plus 8x or whatever it was. Okay. Now, this is -5 times -1 squared, which is -5 times 1, which is -5. So it's negative. Any questions on that? All right, then we just repeat here and here. So f of -1 is -1 times -1 plus 4 squared, which is -1 times 3 squared, which is -9. Ooh. Twist. All right, so f of 1 is 1 times 1 plus 4 squared, which is 1 times 5 squared, which is 25. So that's positive. Any questions on how we got those? All right. So now let's answer the question. Which asks us if x cubed, plus 8x squared plus 16x is greater than 0. So what would you guys put? Which?
Zero.
X has to be greater than 1.
Why
Zero to-
1? Which part of my sign chart is positive or greater than 0?
0 to infinity.
Yeah, right here. Okay, so I think you were looking at this, but 1 was just a number in that region.
Oh, yeah.
Really starts with 0 and goes to infinity, and 0 is not included because we already talked about that. Okay, so that's my final answer. Questions? All right, so we get the question, find our zeros, undefines, put everything on the sign chart, check regions, answer the question. That is the steps in a nutshell. Okay. All right, example 2. 1 is greater than or equal to x cubed plus x minus 2 over x cubed. Now, we prefer variables on the left side. It's just easier to read left or right. So this is, so what I want to do is, if you get a problem like this, my advice, and you can do it without it, but it's just, you're going to have to think a little more. But I would just go ahead and let's reverse these, okay? So let's put the x cubed plus x minus 2 over x cubed over here. You have to make sure your inequality stays pointing that. Okay, so I don't want to change what it's saying. I just want to reverse the order of it. Okay. So saying that 1 is greater than this stuff is the same as saying this stuff is less than or equal to 1. You guys see that? Any questions about what I just did? Okay. Now, we're going to get everything on one side. Let's subtract 1 from both sides. So, so we get x cubed plus x minus 2 over x cubed is minus 1 is less than or equal to 0. All right. Now you could use this. Okay, this isn't wrong, but you will have to do more work throughout the problem. Like you keep redoing the same thing over and over. So it's just easier. Let's combine this into one fraction. So I'm going to take x cubed plus x minus 2 all over x cubed. And 1 is the same as x cubed over x cubed. Is that cool? Just, I'm going to write it with the same denominator, but that means it's just the same thing over itself to make it 1. And so we get x cubed plus x minus 2 minus x cubed all over x cubed. Now something really nice happens for us. These cancel out. Yay. So this is going to be x minus 2 over x to the third less than or equal to 0. And you can see that that fraction is nicer to deal with, right? Okay. So I'm in the end, once I get my sign chart, I'm going to look and see where this is negative or equal to 0. Any questions on what we just did or how we got where we're at? Okay. Moving along. What comes next? Zeros and undefines. Okay. Zeros and undefines. So I'm going to write this. This is my function. F of x is equal to x minus 2 over x cubed. And let's set this thing equal to 0 to get the zeros. Okay. And then let's multiply both sides by x cubed. Okay. Why is it okay to do that now? Why can I multiply by x cubed now?
Because of the equal sign?
Yeah, because it's an equal sign. Okay. So make sure when you're solving for your zeros, you have to make it an equation. Okay. This is where students are just kind of like they slip up and they write it as a absolute, or they absolute value. They write the inequality down. I don't want the inequality. I want the equal sign because the inequality says I can't do this. Okay. So x equals 2. That's my 0. Now, what about undefines? In this case, it's going to be my denominator cannot equal 0. And if I solve this, I take the cube root, so x cannot equal the cube root of 0. Cube root both sides. So x cannot equal 0. So here's the other part that goes on my sign chart. Any questions? All right, once I have those, then we can do our sign chart. I almost wrote sign chart. What the heck was that? That's funny. All right, here we go. 0 and 2. And 0 cannot be included. Can 2 be included?
Yeah.
Yes, because there's this equals here. Okay, so it's okay. It's okay to say 0 is greater, less than or equal to 0. This is okay. We can include. Okay. So now I have 3 regions to check. And again, let me write my function down again. It's x minus 2 over x cubed. So I have 1, 2, 3. 1, 2, 3. All right. So why don't you guys go ahead and do this? Check numbers yourself. You can do that. Pick a number in the region, plug it in your function, see what you get for your sign chart. I'll give you like a minute and a half to do it. Okay, so you should have gotten positive, negative, positive. Any questions or deviations from that? I'm not exactly sure what you mean by that, Joanne. You want to ask out loud, maybe? Do you want me to pause it? That might be a
No,
good
just like
question.
in the beginning,
Uh-huh.
like how it's like starting off, it's less than or equal to 1. Like when I did the homework, I just kind of left the 1 over there and then solved, and I still had like the same zeros you have. I just didn't know if like that was like considered the wrong way, so I don't like keep doing it.
But then when you did did you do a sign chart?
Mhm.
So on your sign chart, did you compare it to 1 or 0?
It was compared to, I think I still had zeros. Like on the sign chart, it'd still be like the 0 and the 2.
Yeah, but then you're asking a
If that
different
makes sense.
question. You're asking if you did it that way, if you did it like this, then when you get to your sign chart, what you're asking is when is this less than or equal to 1?
Okay.
So by putting 0 on the right side, it just is a consistent thing to look for rather than, you know, but you should get the same answer. You'll get the same zeros, you get the same bad numbers, but you're just answering a different question. Does that make sense?
Yeah.
Yeah. So just to be considered, yeah, thank you, Christian. Just to be consistent, I just always put the 0 on the right side, and then we're asking the same question: is it positive or negative each time, rather than greater than or less than to some other number? Okay. Because there are for sure some textbooks, and even if you go out on the internet, if you look for other ways to do this, there might be other methods. I just think this is the easiest way.
Yeah, I was just saying it because like when I did the homework, like the answer was still the same. I don't know if like once I changed it, I just went back to like making it to the 0 or what I did, but it worked. That's why I decided to ask just to see.
Okay. No, that's good. Oh, all right. Thank you. All right. So now we just want to answer the question, right? Answer the question. So I want to know when it's negative. When is it less than 0? That's what we were asked. That's what we got to above. So that's going to be this middle part, right? All right, sweet. So it's going to be 0 not included because that's a bad number. And then 2 is a 0 that's included. Any questions? All right, let me have you guys try this one on your own. This is from Final Exam Winter 11, okay? And it was solve x to the third is greater than negative 3x squared. Okay. So step 1, I would get this. 2 zeros, undefines. 3 sign chart. 4 answer the question. Okay. How about, let me call on somebody. How about, oh, Abil, you've been really quiet today. How do we solve for the zeros here?
Not really sure.
All right, do you see the x cubed plus 3x squared?
Yeah.
All right, so that's just an equation.
Yeah, but I thought we couldn't set it equal to 0 unless it was equal to.
When you go to solve for the zeros, so this is the question, okay? I have an inequality, but when I go to solve for the zeros, remember, zeros are really the x-intercepts, okay? That means your y is 0. You're setting the function equal to 0 so you can solve for the x's.
Oh, okay.
Okay, so these are the places your function's crossing your x-axis. So just looking at that equation, what would we do first?
You can pull out x squared.
Yes. Very good. And then set these equal to 0. So I get x is -3 and x is 0. Is that okay with everybody? Any questions on that? Okay. Now how about Caden? Are you there? What about my undefined part? What are my undefines here? How about Miles? Caden, maybe he's what do you think, Miles?
I didn't get any undefines for it. I just got the zeros.
Good. You can't get any. They're not there. All right, so that's good. All right, so there's nothing that's going to make this undefined. So we only have zeros for, it's a polynomial, okay? Polynomials have no undefines. So here we go, -3 and 0. Are they included? These are zeros. I'm going to put z's above them.
No.
No, very good. So they're not included because there's no equals, right? So I have 3 regions. And again, use this f of x is equal to x cubed plus 3x squared. And let's plug in for each region. But I'm going to use the factored form. Okay. So, all right, how about Shardea? What number should we pick in region 1?
Region 1, I would say -4.
Good. All right, how about Angelica, region 2?
-1.
Good. And Michael, what about region 3?
One.
Yeah, good. All right, very good. So you guys go ahead, plug these in. Let's all use the same ones. Or if you did it already, then I don't know how fast people were working. Some people might already be done with this part. But if you haven't done it already, go ahead and plug these in.
So I got a question.
Mm-hmm.
Like once we get the negatives and positives, what then? Because like I didn't really understand on the last 2 questions what that accomplished.
Okay, that's a great question. Let's finish this part and I'll talk about it again. I'm going to come back to you, okay? That was a Beal, right?
Yeah.
All right, so when you guys did this, you should have gotten, look, here's 16 times -1, -16. So this should be negative. And then here is 1 times 2, which is 2. This is positive. And then 1 times 4, which is positive. So did you guys get negative, positive, positive?
Yeah.
Okay. All right, so now this is what I'm saying about step 4. Step 4 is you have to go back and answer the question or solve the problem, okay? The problem was asking, we put it in this form. I want to know when it's greater than 0, okay? So the last step is solve. So x cubed plus 3x squared, the inequality said greater than 0. Okay, that means my outputs are positive. So you look at your sign chart and you decide where are they positive. Okay, so which regions are those, Abil?
From the -3 to 0 and then 0 to infinity.
Yes. And we cannot include 0. Okay, so those intervals are going to be from -3 to 0, not including 0, but then all the way to infinity. So if you pick a number in either of those intervals, it's going to make this true. Is that a little more clear, Abil, or
Yeah,
still not clear? Okay.
that makes sense.
So the sign chart is just, you can do a sign chart for, I mean, the sign chart is just a tool we use so we can see the answer to that question. All right, one last problem for today. This is a good example because this will happen sometimes. So this is, I think, the 4th one, okay? Let's look at if we have the fraction 1 over x plus 3 greater than or equal to 1 over x minus 4. Okay. All right. So what should we do first here? How about Layla? What would you do first?
Subtract the 1 over x plus 3 to the other side.
You could do that, but what I want to do is get everything on the left side. Let's put 0 on the right and everything else on the left. So then how would that be different?
Can you subtract the 1 over x minus 4 to the other side?
Yeah.
And then put a 0.
Yeah, that would be my advice. It's a little bit easier. So let's subtract 1 over x minus 4 from both sides, and then you're going to get this. Okay. Now, this is fine. Okay, we've got what we want, but again, my advice is let's go ahead and subtract these fractions. Okay, combine into one fraction. Okay. So that's going to require, I'll do it over here just so I don't make this messy, but I'm going to need a common denominator. Remember that whole gig, right? So what's my CD here? How about Hassan? What would you say your CD is here?
12.
Oh, because you're looking at the 3 times 4?
Yeah.
Yeah. Well, it has to be x plus 3, though, times x minus 4. Okay. So I'm going to take this as 1 over x plus 3 times x minus 4 over x minus 4 minus 1 over x minus 4 times x plus 3 over x plus 3. Is that okay, Hassan?
Yeah.
Okay. Okay, then look what happens here. We have x minus 4 on top minus the quantity x plus 3. And it's really important that you subtract the whole quantity. And then my denominator, my common denominator is x minus 4 times x plus 3. So I'm doing the work off to the side here. And then when we distribute the negative, you get x minus 4 minus x minus 3 all over this. And beautifully, kind of nice, these x's drop out. And I end up getting -7 over x minus 4 times x plus 3. Any questions on how we got those two fractions subtracted together?
I just had a quick question.
Mhm.
I thought you said we couldn't like add or subtract variables. Is that just variables on its own?
You can't multiply or divide by variables across the inequality.
Oh, okay.
Like on both sides, you can't like do times x over here and times x over there, or divide both sides by x. You can add and subtract anytime. Okay. So this is going to be -7 over x minus 4 times x plus 3, which you can see is just a little bit easier. It's all together. So here's my question. I want to know when that function is going to have positive outputs or greater or equal to 0. Leave the denominator factored because it's just easier to calculate with it factored. Okay. All right. So how about Andrew? What do we do next?
For the next part, you said me, correct?
Mm-hmm. Yep, I did.
For the next part, wouldn't you just do the factor for the x minus 4 in the denominator? Like to find the, like put it equal to 0?
So which part is that? Is that finding the zeros or the undefines?
Wouldn't that be the finding the zeros? Or actually, no, the undefined.
Yeah, it's the undefines. So that's one thing you can do. Take your denominator, and I got to find when it cannot equal 0. Okay, because those are the numbers we're going to have to exclude.
See, I was like looking at it like that, but in my head, I was thinking that's like finding zeros just because like you're finding what doesn't equal to 0. But I got you now. Thank you.
Yeah. I can see how that would be a little bit like confusing. Yeah, I see that. Because you're solving for 0 here too, but because you don't want to include them. So so x plus 4 cannot equal 0. X plus 3 cannot equal 0. I'm sorry, this is supposed to be -4. So x cannot equal 4 and x cannot equal -3. So those are undefines. Okay. Now, zeros, I'm going to take my function. Remember, zeros are x-intercepts. How do we find these? How about Chris? What do you think, Chris? What should we do?
You'll set it equal to 0. But then
Yeah. I'm going to set the whole thing equal to 0 and solve it. Okay. So you see the difference? Undefines and bad numbers, I'm just looking at the places where they would be excluded. Zeros, I want to find where this function will be 0 overall. So if I multiply both sides by my denominator, I'm going to clear fractions. Okay, so clear fractions, which I can do because it's an equal sign. It's an equation, so this is okay. And I end up getting -7 equal to 0. Huh, that's strange. What do you guys think that means about our zeros? What are my zeros? Miles?
I said there's no zeros.
Yes, very good. Okay, when you get something that is no solution, that means there are no zeros, i.e. no x-intercepts, which means this graph never crosses the x-axis. Okay. All right. So now we're going to do our sign chart. And the only thing I have to put on here are my undefines. And they're never included. Okay. Doesn't matter. We don't even need to look at the inequality. They're just not included. All right. Now there's 3 regions here. And I'm going to show you guys something a little bit different. So I'm going to pick X is -4, X is 0, and X is 5. Those are the 3 we're going to check. Now, here's my function. F of X is equal to -7 over X minus 4 times X plus 3. Now look at this. If I plug in -4, that's going to be -7 over -4 minus 4 times -4 plus 3. Well, we're just going to calculate this. So it's going to be -7 over, this is -8 times -1. So you see how you get -7 over a +8. So this is negative. Any questions about that? Okay, f of 0 is going to be -7 over 0 minus 4 times 0 plus 3, which is -7 over -12, which actually comes out positive. So the middle is positive. And then f of 5 is going to be -7 over 5 minus 4 and 5 plus 3. So you get -7 over 1 times 8. So that's going to be negative again. Any questions on how we got that? Okay, now I got to answer the question. So I want to know back when it's greater than or equal to 0. So -7 over this. Where would we pick? How about Glycaria?
I'm not sure.
Okay, so let's look at the question again. I want to know where this is going to be greater than or equal to 0. So look at the sign chart. Which portion do you think that is?
The second column.
Yeah, very good. That's where it's positive. So greater than or equal to 0 is positive. So I'm going to put from -3 to 4, that's the interval. And since it has undefines on the ends, we don't include those. So all the numbers that will make this true occur between -3 and 4. Questions? I want you guys to have like a little bit of a visual of this graph for real quick. I know I'm almost out of time here, but what is this graph really looking like? The undefines are -3 and 4. Those are going to be what we call vertical asymptotes. It's going to look like that. And the middle part is above. So it's going to do something like this. And then do you see how the ends on both sides is negative? That means my graph is going to do something like this. Okay, so that's not an exact measurement, but you see this graph, this is the negative region below the axis, this is the positive above, and this is the negative below. And it's never going to cross the x-axis either. That's why there's no zeros. So you guys kind of see that? All right. I will see you tomorrow. Everybody have a good day. I'll stay for a few minutes if you have questions.